Okay, here we go. Last one. All right. So once again, just like the previous problem with the radical, if we want to do the algebra, then we tell it, hey, the inside has to be positive, or 0 is fine as well. Non-negative is the math term. And so if we have a square root function, then I'm going to say, hey, the inside needs to be non-negative. It needs to be greater than or equal to 0. And so then I have a quadratic inequality, ladies and gentlemen. You were just tested on this. We can double bubble. Remember, we cannot really solve quadratic inequalities. Linear inequalities are super easy, all right? But anything higher is much, much harder. So we need to find the critical points and then ask ourselves, hey, where is it positive? Okay. Because the inside has to be, we can't have any negative numbers. So we say that the inside must be greater than or equal to 0. We can't take the square root of negatives.
Yes, squared.
All right. So I'm going to go ahead and double bubble right now.
The square root is always more than or equal to 0. Always.
Always. All right. Jacob, how does it double bubble? X minus 8 and x plus 3. Good. All right. So what I'm finding are actually the zeros here. We get x equals 8 and x equals negative 3. So I'm going to plot those. These are the zeros where our function is equal to 0, or also known as the x-intercepts. And we need to do a little sign chart. So I'm going to go ahead and just have you, let's go ahead and graph. It would be a parabola, so you know the graph in your head. All right, so yes, that's good. But when in doubt, graph it out. So I'm putting this parabola in my calculator, and we know it crosses at negative 3 and 8. And I'm just going to do a little sign chart. You don't have to draw the graph, but we're looking for positive values. So I'm going to pick a number. What's to the left of negative 3? Negative 4. So I'm going to trace negative 4. And I got positive 12. So that's a big giant positive. Everything to the left of negative 3 is positive. What's between negative 3 and 8? 0. So I'm going to trace 0 and I get negative 24. Everything between negative 3 and 8 is a negative value. What's to the right of 8?
That's what you.
9. 9 gives us a positive result. Everything to the right of 8 gives us a positive result. So what is our interval?
So negative infinity, comma negative 3, bracket u 8 to.
All right. So all of these x values from negative infinity to negative 3. How come I'm using a bracket at negative 3? Because we're allowed to equal 0. And then also from 8 to infinity, again with a bracket, because we're allowed to equal 0. This is the inequality notation for the interval notation. The inequality would be x values less than or equal to negative 3, or x values greater than or equal to 8. And that's the domain. So now the nice thing is you can also plug the original function. That's how you do it algebraically. The original function could go in your calculator as well. The square root of x squared minus 5x minus 24. Look at this craziness.
Oh, yeah.
It's a square root swoop, right? Well, that's what happens.
Yeah, I put that in my calculator. I was like,
Yeah, it goes, what? Okay, yeah.
It like dives into the water where you can't see it, and then it pops out.
I put in this original. Yeah, so this is the picture of the original function.
That's just funky. I get it, but it slaps the base.
I didn't.
Oh, this.
Okay, got it.
All right, so when you look at this function, you'll notice how far left does this graph go? Yeah, it goes forever off to the left. And then it comes in here, and if you trace and type in -3, it is actually 0 there. Your calculator does not have a retina display. It has a hard time graphing sometimes. But it does go from -infinity all the way here to -3. And then if I trace 8 again, you can see it's 8, 0. So there's Tinkerbell right there, and it goes off to the right forever. So that's where it picks up at 8 and goes off to the right forever. So you can, when in doubt, graph it out.
So that touches 0?
It does. Yeah. Literally the graph is at -3. It's a square root swoop. And at 8, it's another swoop. They are, split swoops. Okay? All right, ladies and gentlemen, you will probably need to take this home to finish your homework. And you turn it in tomorrow.
It's pretty solid.
All right. Do you have any questions?
No.
Use your calculators when in doubt.